talking about today is the normal distribution, finally. So we're going to be calculating probabilities. I'm going to show you how to calculate each probability 2 different ways. We're going to use a table, and then we're going to use a calculator. And then we're also going to go backwards. So if I give you a probability, you need to find a certain value. First off, this is at the top of your notes. This is how important normal distributions are. This is currency, and I'm going to be honest, some country, I don't know what country, but it has the normal distribution on the currency. That's pretty cool, right? Come on, that's pretty cool. Look at that.
Wow. Definitely. Wait, it says it's German.
Okay, it's German. I don't know. Okay.
Okay.
The point is, the normal distribution is on their currency, so it's really important.
So do you want some money from there? I feel like that would be something you want.
Kind of.
Why is on?
Because it's important. I don't know. Okay, moving on.
Really good idea.
So, first thing that we're going to do is we're going to talk about the standard normal distribution. Standard normal distribution means that the mean is 0, the standard deviation is 1. Standard normal distribution is a z-score. So anytime you convert something to a z-score, it's automatically the standard normal distribution. These are the probabilities that we're going to find. So you might want to draw, you're going to need this curve for each of the 3 examples. So you have 3 examples, draw yourself 3 curves. Label the standard deviations, please. Okay, just do the first one. You can do the other diagrams later, okay? Probability that z is less than negative 3.16. Anytime you have a problem like this, you need to mark where it is. So this is negative 3.16, and you need to show me what you're calculating. So the probability is everything to the left of it. There's 2 different ways to calculate this probability. The first way is using a table. So that's why I gave you these green tables today. Is if you go to table A. Table A, it's the first table. It's this one right here. It says standard normal probabilities. Okay, so this table always shows you the probability below a specific z value. All you have to do is look up that z value. So ours is negative 3.16. So you go to negative 3.1, and then you go all the way over to 0.06. So negative 3.16 is 0.0008. Did you guys see that? Yes. Okay, that's the answer, 0.0008. Okay, the reason that I make you draw the figure is so that you can verify your answer. What is the area for the whole figure?
1.
1. Does this look like it's about 0.0008? Yeah. So, that's the first one. Second one. The probability that z is between negative 0.5 and 1.21. So negative 0.5 is here. 1.21 is about here. We're looking for the probability of being between. Okay, so the z table only does below a specific value. So you can't look up between negative 0.5 and 1.21 so easily. Instead, what you're going to have to do is you're going to have to calculate the probability that z is less than 1.21. So that would give us all of this. And then you're going to subtract the probability that z is less than negative 0.5. So I'm calculating this and then subtracting the white tail, which will leave me with the red part. So, probability that z is less than 1.21. This is the negative side. If you flip the table over, that's the positive side. So you go to 1.2, go over to 1, and you get 0.8869. Please make sure you're looking these up with me so that you make sure that you know how to use this table as well as I do. Did you guys get that? Yeah? Okay. So then, less than negative 0.5, you're going to have to go back to the negative side. And it'll be negative 0.5 and then go over to 0, which is 0.3085. Kate, did you happen to subtract that?
0.5784.
84?
Yeah.
Thank you. Okay, does our red probability look to be about 0.5784? Yes. Okay, last one we have is greater than 2.5. So here's 2.5. Here's everything greater. There's actually two ways we can calculate this. Can you guys think of either way?
Could you do 1 minus the probability that Z is less than 2.5?
So that's the first way. 1 minus the probability that Z is less than 2.5. So let's do that. Look up less than 2.5. So it'll be on second side where all the positives are. I get 0.9938. You guys agree?
Yeah.
So that's
0.62.
Thank you. 0.0062. So that was the first way to calculate it. What's the other way that you can calculate this?
Probability is Z is less than negative 2.5.
Yeah. It's going to be the same as the probability that Z is less than negative 2.5 because of the symmetry of the normal curve. So if you look that up, we should get 0.0062. And if we don't, then something happened. You get 0.0062?
Yeah.
Okay. How do we feel about the normal table? Not bad? Okay. Awesome. Questions before we move on? Okay. For the next examples, we're going to be working in the opposite direction. So in this case, I gave you a z-score and I asked you to find a probability. Now I'm going to give you a probability and ask you to find a z-score. So the first example, we are going to find the z-score that corresponds to the smallest 2% of the distribution. Okay, so smallest 2% is going to be somewhere over here. I don't know where, so just pick a spot. We don't know what the z-score is, so I always mark it as z star. And then shade, and that probability is 0.02. It's the lowest 2%. Okay, so now we know that the probability that z is less than this z star, whatever our z-score is 0.02. So the probability of being less than this value is 0.02. We need to find the z-score, or the z star. So all you do is look on your table and find 0.02. So this is a little more tedious, so you just gotta search. Anybody find it yet? Dexter?
Negative 2.05.
Yeah, it looks like it's between negative 2.05 and negative 2.06. Anytime that your value is between the two, you just average them. So we're going to say that z star is the average of negative 2.05 and negative 2.06. So we're going to say it's about negative 2.055. That's just an approximation. It's not exactly that, but it's close enough for us. Okay, we need to find the z-scores that correspond to the middle 95%. So there's going to be two scores, one on the bottom, one on the top. So this is going to be the negative z-star. This will be the positive z-star. What should it be around the middle 95%? Think empirical rule.
2.
Should be around 2. So I'm going to draw it a little more accurately. Okay, so then all of this right here is 95%. Now, because of the symmetry of the curve, they're going to be the same value. One's going to be negative, one's going to be positive. What are we going to look for on the table for the middle 95%? 0.025. So the probability that z is less than our negative z star, so that's all of this, is 2.5%. So 0.025. So now you gotta search on the table and find 0.025. Yeah, this one's on there exactly. Negative 1.86.
No. 9.6.
96? Oh, yeah. Negative 1.96. Okay, so we're going to say our negative z star is negative 1.96, and then our positive z star is 1.96. So any values between negative 1.96 and positive 1.96 fall within the middle 95%. Okay, top 5%. If I mark this on my figure, is it going to be to the left of z star, the red one, or to the right of z star? To the left, right? So this is the upper 5%. So in this case, I know that the probability that z is greater than my z star is 0.05. What am I going to look up on the table? Because the table does not do upper. What are we looking up on the table?
95?
Yeah, look up 95%. So if z is greater than z star 5% of the time, that means z is less than z star 95% of the time. So greater 5%, lower 95%. So then you find 0.95. I have 1.64 and 1.65 between the two. So you say that z star is the average of, what did I say, 6.4 and 6.5?
Yeah.
It's the average of 1.64 and 1.65. So it's about 1.645. Okay, how do we feel about the table? Not bad? Okay. Do we have any questions before we move on? Okay, that was the standard normal distribution. That is just one normal distribution. There's a ton of different normal distributions. They're all defined by the mean and the standard deviation. So what happens when we change the mean and the standard deviation? So that's what we're going to do on the next page. So if you can flip the page. Okay, so we are going to look at the heights of adult U.S. women. So adult U.S. women have heights that are approximately normally distributed with a mean of 65.5 and a standard deviation of 2.5. I like to change the numbers here, so don't copy down my numbers. So the first one that you have is the probability of some woman being less than some height. Who's the shortest female in here?
I'm 5'3".
5'3". Okay, so 63 inches. Okay, so let's figure out what proportion of women are shorter than Brooke. Is anybody shorter than 63 inches? You're 5'2". Okay, well you're close to 63. Okay, so first thing that you're going to do is convert it to a z-score. So that W changes into a z. The z-score is take your value, subtract the mean, divide by the standard deviation. Oh, whoa. You guys didn't tell me I went to a new slide.
Oh.
You went to a new slide.
Thank you. That was helpful now.
You're welcome.
Okay, what's 2.5? Oh, that's so nice. It ends up being -1, right? Okay. So, I forgot to tell you something. You need to mark the mean and the standard deviation on your figure. So the mean is 65.5. So that goes below 0. You're always going to double label the figure. So you're going to label the figure with the standard normal labels and then with the context of the problem. So our standard deviation is 2.5, so now we need to add 2.5. So this will be 68, 70.5, 73. Somebody verify that I added correctly. I did? Okay, thank you. Okay, we're going to label Brooke on here. So this is Brooke. These are all the women that are shorter than her. Now we're going to use the table. You guys use the table right now. So find the probability of being less than 63 inches or -1. Should get 0.1587. Yeah? Okay. So this is the way to do it on the table. Would you guys like to know how to do this on the calculator?
Yeah.
Good, me too. Here are your calculator. Both ways work. You need to know both ways, but then you can pick whichever way you prefer. So we've done this on the calculator before. You're going to go to second distribution and choose normal CDF. The way that normal CDF works is you have to put in your lower bound, your upper bound, your mean, and your standard deviation. So in our case, the lower bound is -infinity. Obviously, you can't put -infinity in your calculator. So the closest that we can get is just do -1 times 10 to the 99. You guys know how to use the E button, right? So really I want you to do -1 E99. Okay. Then our upper bound is this -1. So you do comma, -1, comma. It's the standard normal curve. So on the standard normal curve, the mean is 0. And then the standard deviation is 1. And you should get about 0.1587. Did you?
What's the thing? What's below it? Oh,
This is how I want you to do it on the calculator. Okay. Good with that one? Okay. Let's do another one. Okay. So now we're looking for between two values. Less than and less than or equal to don't matter because it's continuous. So let's do between Marta's height. Marta, you said you're 5'2", so 62 inches. Who's the tallest? Female.
I'm 6'1".
Female.
Oh.
Greta, how tall are you?
5'9".
Is anybody taller than 5'9"? You?
5'10".
5'10", so 70 inches, right? I just want to verify that I'm adding correctly. So we're going to find what percentage of women fall between 62 and 70 inches, so between Kate's height and Marta's height. What's the first thing that we're going to do?
Convert to a z-score.
Convert to a z-score. So this is going to be 62 minus 65.5 all over 2.5. As soon as you do that, the W changes to a Z because it's now a different distribution. Can somebody tell me what those values are?
-1.4. And 1.8.
Of course, we need to mark this on the figure. I forgot to do that. So 62 is about here. So you would put 62 inches, and then above it, I want you to put the Z-score. And then over here is our 70 inches, and above it, the z-score of 1.8. And then highlight to tell me that this is all the stuff that you're looking for. So, in the calculator, you're going to need normal CDF. Our lower bound in this case is negative 1.4. Our upper bound is 1.8. Our mean is 0. Our standard deviation is 1. I got 0.8833. So about 88% of women will fall in that range. How would you do this on the table if you wanted to do the table instead of the calculator? Justin?
Take 1.8 and subtract it from 1.8, probability of 1.8 and subtract it from probability.
Yeah, so on the table you would have to find less than 1.8 and subtract less than negative 1.4. Justin?
So on the quiz, are you asking you want us to write that one then? The probability of z being less than 1.8 and this probability of z being less than negative 1.4?
On a quiz, I would just expect to see this work. That's it. So like for B, I would expect to see this, that, and your answer. So I don't care what you use.
Why is your mu and your standard deviation 0 and 1 not like what it gives you?
Because as soon as you convert it to a z-score, it's now the standard normal distribution, which means the mean 0 and the standard deviation is 1. Okay. Let's do C. Let's just do the one that's there. Find the probability of a woman being taller than 72 inches. You guys do this one. I would like you to use both the calculator and the table. Hopefully now the calculator will do it for you. But this is consideration. So you can do that to check your answer, but I still want you to convert it to just to show it. Okay, here's what I got. When I converted to a z-score, I got 2.6. Yeah. And then a probability of about 0.0047. You do normal CDF. The lower bound is 2.6. We're going to positive infinity, 0, 1, which gave me that. On the table, to get greater than 2.6, you do 1 minus less than 2.6. How do we do? Fine? Okay, great. Last thing. Now, working the other way. So if I want to know how tall a woman has to be so that she's in the bottom 1%. So first thing that I want you to do is label your figure again. So we have the standard normal labels. Okay, so if she's in the bottom 1%, what percentage of the data is below -2? About from the empirical rule?
0.024.
About 2.5% below -3? 0.15%. So she's going to be somewhere here. Okay, we're going to start by finding a z-score. So the probability of being shorter than that z-score is 0.01, which is the bottom 1%. So look on your table, find 0.01, please. You should get between -2.32 and -2.33. Yeah, you guys agree? Okay. So our z-score is the average of -2.32 and -2.33. So our z-score is about -2.325. And now you need to convert that back to a woman's height. So now you would do -2.325 equals the height minus the mean all over the standard deviation. So if we multiply by 2.5 and then add 65.5, we get a height of 59.6875 inches. Based on our figure, that makes sense. It's less than.
That should be 6. It should be 63 and then 60.5.
This should be 63.
Mm-hmm.
Okay. That makes more sense. Thank you. Okay. Comfortable with that? Yeah? Okay, middle 50%. Middle 50% is going to correspond to 25% and 25%. So within one standard deviation is 68%. So the middle 50% is going to be somewhere here. So it's going to be less than one standard deviation. So this is 50%. So we have these two z-scores. They're going to be the same, one negative, one positive though. I'm going to look at this left tail, which is 25%. So the probability of being less than that negative z star is 0.25. It's the bottom 25%. Do you guys know how to find that on the table? You would look for 0.25, right? Okay, we're going to do it on the calculator instead since you know how to do the table. On the calculator, you're going to do that second distribution again. But this time you're going to choose inverse norm. The way inverse norm works is you put in a lower probability, a mean, and a standard deviation. So I'm going to put in my lower probability of 0.25, my mean of 0, my standard deviation of 1. And you should get negative 0.6745 about. So that means that this z-score is negative 0.6745, and this one is positive 0.6745. And then you would convert both of them back to heights. You feel comfortable converting? Okay, in the interest of time, we're going to move on then. Last one, if you're in the top 2%. So you're somewhere here. If you're in the top 2%. So the probability of z being greater than that value is 0.02. Okay, on the calculator though, the calculator only does the lower probability for inverse norm. So it works kind of like the table. Table has to be a lower probability. So instead of putting 0.02 in your calculator, you would do inverse norm of 0.98, comma 0, comma 1. And you should get 2.054. Okay, so that means that your z-score is 2.0554, which you then would convert back to a height. Okay, being open and honest with me, how do we feel about this?
Okay.
Yes?
Yeah. For the last one.
What the height would be? No. Okay. Like I said, you need to know both the calculator and the table, but you can choose whichever one you prefer.